Artificial intelligence, or AI, is the exciting field of making computers think like humans. Machine learning is a key part of AI. It lets computers learn from data without explicit programming. Imagine teaching a computer to identify cats in pictures. Instead of giving it specific rules, you show it many cat pictures. The computer learns the features of a cat by itself. This is the power of machine learning. Machine learning has many applications. It's used in self-driving cars, medical diagnosis, and personalized recommendations. By analyzing large datasets, machines can learn patterns and make predictions. This ability to learn from data is revolutionizing many industries. Convolutional neural networks, or CNNs, are a special type of neural network designed for processing data with a grid-like structure. Images, for example, are grids of pixels. CNNs are particularly good at image recognition tasks. They can learn to identify objects, faces, and even emotions in images. Unlike traditional neural networks, CNNs use convolutions. A convolution is a mathematical operation that blends two functions to create a third function. In the context of CNNs, convolutions are used to extract features from the input data. These features are then used to classify the input. A typical CNN consists of several layers. Each layer performs a different operation on the input data. The first layer might detect edges and corners, the next layer might detect shapes, and so on, until the final layer, which makes a prediction about the input. The convolution operation is at the heart of a CNN. It involves sliding a small filter over the input data. This filter multiplies its values with the corresponding values in the input data. The result of this multiplication is a single number. This process is repeated for every possible position of the filter on the input data. The output of all these convolutions is a feature map. Imagine you're looking for your keys on a cluttered table. You wouldn't examine every single object on the table at once. Instead, you'd scan the table with your eyes, focusing on small areas at a time. This is similar to how a CNN works. The filters in a CNN are like your eyes, scanning the input data for specific features. Another analogy is to think of a CNN as a detective solving a crime. The detective gathers clues from the crime scene, analyzes them, and uses them to identify the suspect. Similarly, a CNN gathers features from the input data, analyzes them, and uses them to make a prediction. Section 5. CNNs in action real-world applications. Convolutional neural networks, or CNNs, are used in a wide range of applications including image recognition. CNNs are the state-of-the-art in image recognition. They're used in self-driving cars to detect pedestrians and other vehicles, in facial recognition systems to identify individuals, and in medical imaging to diagnose diseases. Speech recognition CNNs can also be used to process audio data. They're used in virtual assistants like Siri and Alexa to understand voice commands, and in speech-to-text software to transcribe spoken language. Natural language processing CNNs are increasingly being used in natural language processing tasks, such as sentiment analysis, machine translation, and question answering. Section 6. The future landscape of CNNs, trends and research. CNNs are a rapidly evolving field. Researchers are constantly working on improving their accuracy, efficiency, and interpretability. Some of the current trends and research areas in CNNs include deeper networks. Researchers are building deeper and more complex CNNs to solve increasingly challenging problems. Transfer learning. Transfer learning allows CNNs trained on one task to be used for another task. This can save time and resources when training CNNs for new applications. Explainable AI researchers are developing methods to make CNNs more interpretable. This is important for building trust in AI systems, especially in sensitive domains like healthcare and finance. Section 7. Conclusion. Convolutional neural networks have revolutionized the field of artificial intelligence. Their ability to learn complex patterns from visual and audio data has led to breakthroughs in image recognition, speech recognition, and many other areas. As research and development in CNNs continue, we can expect even more innovative applications in the future. Section 8. Like, subscribe, and stay updated. If you found this essay insightful and want to explore more about the fascinating world of AI and machine learning, don't forget to like this article, subscribe to our channel, and turn on notifications to stay updated with our latest content.